Hi guys, in this video let's explore one of the most powerful ideas in modern artificial intelligence, that is deep neural networks. These networks form the core of deep learning and power many real world applications such as image processing, speech recognition and language translation. Okay, up next is what is a deep neural networks. A deep neural network is an advanced type of artificial neural network that contains multiple hidden layers between the input and the output layers. These multiple layers allows the model to learn complex hierarchical representations from data, which makes deep neural networks highly effective for modern AI tasks. You can think of a DNN as a stack of layers where each layer learns a more abstract feature than the previous one, moving from raw data to meaningful patterns and finally to useful prediction. Because of this layered learning, DNN have significantly advanced the overall field of artificial intelligence. Okay, the next part is the architecture of a DNN. The architecture of a DNN typically consists of four main components: the input layer, multiple hidden layers, the output layer, and the activation function. The input layer receives raw data such as images, text, audio signals, or numerical features, and this layer only passes the data into the network without performing any computation. In the hidden layer, lower layers usually learn simple patterns like edges in images, while deeper layers learn higher level concepts like objects or the meaning of the text. Finally, the output layer produces the final prediction, which could be a class label for classification or a numerical value for regression using suitable activation function. Then what is activation function? Activation function introduce non-linearity into the network, which is essentially for learning complex patterns instead of just linear relationship. Common activation functions include linear, ReLU or sigmoid and tanh. Up next is the working of a DNN. This involves forward propagation, a loss function, backward propagation, and optimization algorithms. In forward propagation, input data flows from the input layer through all hidden layers to the output layer, and at each neuron, the computation y is equal to f of wx plus b is performed to transform the data step by steps. Once a prediction is obtained at the output layer, a loss function is used to measure the difference between the predicted output and the actual output, with common loss function being mean squared error and cross entropy results. Next comes the backward propagation, which is the opposite of forward propagation. This is the core learning algorithm of DNN and update the weights by calculating the gradients of the loss with respect to each weight. By propagating these errors backward through the network, backward propagation helps minimize the loss and improve the accuracy of the model over time. To make this process efficient, optimization algorithms like gradient descent, ADAM, and RMSProp are used to adjust weight in a way that speeds up converges and improves performance. Together, forward propagation, loss computation, back propagation, and optimization form the basic working cycle of a deep neural network. Next, we can see the training process of DNN. Training a deep neural network involves repeatedly running that working cycle over many iterations or approaches. The typical steps are: initialize the weights randomly, perform forward propagation to compute predictions, calculate the loss using a suitable loss function, apply back propagation to compute gradients, and then the last to update weights using an optimization algorithm. These steps are repeated for multiple approaches until the desired accuracy. Next, we are going to see the important features of DNN. Deep neural networks have several important features that make them powerful. One key feature is hierarchical feature learning, where lower layers learn basic features, middle layers learn patterns, and higher layers capture full concepts. Important feature is non-linear modeling, where activation function enable the network to learn highly nonlinear relationships between input and output. Then we can see the types of deep neural networks. There are several specialized types of DNN. Convolutional neural networks are widely used for image and video processing tasks. Recurrent neural networks are used to sequence data like speech, text, and time series. Autoencoders are used for dimensionality reduction and noise removal, learning compressed representations of data. GANs or generative adversarial data. Deep neural networks are used in many modern technologies such as facial recognition systems, medical image diagnosis, NLP, self driving cars, speech recognition systems like Siri and Google Assistants, etc. They are also used in recommendation systems like YouTube and Netflix. Their advantages include very high accuracy on complex tasks, automatic feature extraction without manual feature engineering, the ability to handle high dimensional data, learning of non-linear relationship, and good generalization. To sum up, deep neural networks are among the most powerful tools in modern AI and in many ways replicate aspects of the human brain learning process. They can solve problems that are very difficult or even impossible for traditional machine learning methods, and they form the foundation for advanced technologies like autonomous vehicle, NLP, and modern medical system. Despite their challenges, the ability of DNN to learn deep features and deliver high accuracy makes them essential in nearly every industry today. Thank you for watching, and if you found this explanation useful, consider liking the video and subscribing for more AI and deep learning content.